Hi, this is Mr. Mac, and this is the concept video on absolute value equations. First of all, let's take a look at absolute value. Years back, you were told, for example, that the absolute value of 2 was 2, and the absolute value of negative 2 was 2. And basically, you were probably told that this number represented the distance of the value inside the absolute value from 0. And if you look at a picture of a number line, two is 2 units away from 0, and negative 2 is 2 units away from 0. Now you probably have said in your mind that the absolute value symbols just take away any negative sign that might be there. And in a way that's true. If we were going to define absolute value though, in other words, if we were to define the absolute value, we would say the absolute value of x is either, and we're going to use a mustachio here, or a set brace, it's x if x is greater than or equal to 0. Now think about that for just a minute. If x is greater than or equal to 0, that means x is either 0 or positive, because any number to the right of 0 on the number line is positive. Then the absolute value of x is just the number inside. Now, we also say that it's the opposite of x whenever or if x is less than 0. Now, x is less than 0 means x is negative. And when x is negative, or if the value inside the absolute value is negative, then we drop the sign, or we take the opposite of it, because the opposite of a negative number is positive. So it is true that the absolute value always gives us either positive value or 0, but the definition looks a little strange because sometimes the absolute value of x is the opposite of x. But that would only be when x is negative, and then the opposite of x would be a positive number. Now if we take this a little bit farther, if we have a variable inside absolute value, for example, if we say the absolute value of x is equal to 2, what we want to do is we want to figure out or identify the numbers that we could put in for x that would make this equation true. Now, of course, we know that the absolute value of 2 is 2. So one of the solutions would be x equals 2. But if you think about it, there is another value that when you take its absolute value, you get 2. And that would be negative 2. So we also know the absolute value of negative 2 is 2. So x could be negative 2 as well. And we usually connect those with the conjunction or. In other words, if the absolute value of x equals 2, then x is equal to either 2 or negative 2. Now that suggests a way to solve absolute value equations. If you have an absolute value and it's equal to a number, you can drop the absolute value by saying, well, the part that's inside absolute value is equal to either 2 or the part inside the absolute value, x in this case, is equal to the opposite of the number, negative 2. And that can be used to solve absolute value equations. Now let's take a look at an equation and see if we can't. I'd like a new page. Where do I get A new page. Well, let's try this. We'll get a new page this way, and then we'll just go back to the full screen. Now let's imagine we have the absolute value of 2x minus 1 equals 7. By what we just learned before, what's inside the absolute value, 2x minus 1, has to either be 7 or what's inside the absolute value, 2x minus 1, has to be equal to negative 7. So you need to look at this a little bit and see the logic behind what we've done. Once we have an equation where we have the absolute value on the left-hand side and a number on the right-hand side, we say, well, what's inside when we absolute valued it was 7, or when we absolute valued negative 7, so what's inside could be negative 7, and when we absolute value it, we also get 7. So 2x minus 1 could be either 7 or negative 7. You might want to stop the video at this particular point and think about that for a minute. Maybe replay what I just said. But now, solving these equations, this takes us back to solving linear equations. Add 1 to each side. On this one, we get 2x equals 8. Divide both sides by 2. We get x equals 4. Or, add 1 to both sides here. We get 2x equals negative 6. Divide both sides by 2, we get x equals negative 3. Now, if you look back, let's see if this makes sense. The left-hand side, if we use 4, we have absolute value 2 times 4 minus 1. Now, the absolute value of 2 times 4 minus 1 is 8 minus 1 absolute value, which is absolute value of 7, which is 7. So you should see that 4 actually does work. Now, let's look at this one. The left-hand side of the equation, absolute value, 2 times x. Now, we decided this time it was negative 3 minus 1. Now, that's the absolute value of negative 6 minus 1, or the absolute value of negative 7. Now, look at this carefully. If we take the absolute value of negative 7, we get 7, which is what we wanted, the equation. That was what we wanted here. So negative 3 also works. So when you're solving an absolute value equation, first, if there's anything outside the absolute value on the left-hand side, peel it away by using APE and MPE or whatever you have to do, and then you split the absolute value equation into these two equations. What's inside the absolute value is equal to the number, or what's inside the absolute value is equal to the opposite of the number. Now, there is one thing to watch out for. If you had something like this, absolute value 2x minus 1 equals negative 2. Now, when we take the absolute value of whatever's inside, if it's positive or negative, it will be positive. And so we can never get a negative number when we take the absolute value. So in a case like this, where we have the absolute value is equal to some negative number, there will be no solution to that equation.